and welcome back to another episode of the Game Engine series. So what are we doing today? Well, I know I promised you all we're going to get to our event system, and I'm going to promise you again, next episode. I promise we will get there, but there was just a little bit more setup and a little bit more kind of like pre-work that I wanted to do before we started that, which will make our lives a lot easier once we get there. So yeah, so event system, next episode, I absolutely promise this time. But so then what are we doing today? Well, we're going to first add some logging. There's actually quite an easy way to do this in Zig, how you can just use std.log, but I want to show you how to take it a step further and just add like colors to your log. So you can have like your normal debug, info, warn, error, but make them various colors, make it very clear in your terminal what's happening. So yeah, so I want to add logging. But the other thing I want to do is also just abstract our window a bit. Right now, we still are using a lot of the GLFW functions right in our run function. So I'm just going to abstract it out to a window struct, kind of make it easier to work with, just like we did with OpenGL last time. But now we're going to do it with our window. So I hope you guys still find it interesting. I hope you're enjoying the series. If you do, I'd really like subscribe, like, comment, really anything, just let me know. But if that's all, let's jump into the code. Just one thing I want to do right before we get into the code is I want to give a progress update of where we are at with the game engine. So if I just run a code, we can see here we have our editor. So it's interactable, can move around, look around. We have some basic lighting. You see there's light coming in from here and shadows darker down here. Yeah, so I think that's one cool thing. And also there's a release mode. So this strips the actual editor itself and just this is the game. So if you're excited about that, make sure you stay tuned, make sure you subscribe and keep watching because we're going to get there. And it'll take some time, but I just want to give a progress update to get people excited. Okay, now that we've done that, we're back in the code. So I just want to start by fixing up some things I noticed last episode. Like one right here, we should be passing the fragment shader instead of the vertex shader. And that was the actual only mistake I found last time, but there's one other thing I wanted to clean up. And that's I don't want our run function to actually return a function. I want to fully be able to handle things itself. So we can just call it like this. And then the one place where we call try, what we're actually going to do is catch the error and then just log it. So debug print error creating shader. We'll print the error and just return early. So what does this look like? Well, if we go back to our fragment shader, and now we remove, let's just say semicolon, and we run that, we can see expecting, we see semicolon, and now there's no call stack because we're handling the error, but we can still see exactly what we need, fragment shader, and all that. So now if we do this, there we go. So add semicolon back and it'll run again. Okay, but I promised logging, so let's get into that. So what we're going to do is create this core folder, and inside of core, we're going to just add log.zig. And now that we're here, let's just start writing it. So I'll explain it as we write it. Let's start with our imports of std, and this time we'll also need built-in. Okay, so next we're going to represent some colors. So we'll do that with this struct, and this will just be the different colors of our log levels. And also an extra one for just proper printing, which is this first one. And so then we'll get the 4 levels. So for red, orange, blue, and green. Now let's set the proper values, and that's going to be 31, 33, 34, and 32. Perfect. So now we have the colors. So these we will use in our log function. So if you don't know how log works in Zig, we are going to write this function, this log function ourselves, that will essentially tell Zig, like, it'll call this function to do printing if we choose to. So we can overwrite the built-in log, which is exactly what we want here. So do type of and enum literal, and all these being comp time is nice because we know it's can be fast and efficient. And it has to follow this format that just, or these parameters, that just the function arguments that it expects to call with. So I'm going to do one optimization off the bat, which just is at compile time, which is nice. So if mode is release fast, so like our release mode, and level equals debug, we're just going to return early. So this is essentially going to be a no-opping function where we just strip all our logs or debug logs in release mode. So that means we can add logs wherever we want. We don't have to worry about performance implications in release. So that's really nice. And now let's get the color. So this one can also be determined at comp time. And color red. And then we'll just handle all the cases. So warn, info, debug, and then that'll be orange, blue, and green. Nice. So now we're going to actually write the log itself. So we're going to write a couple prefixes, which just will help our logging. But I'll try and point it out when we actually get to, like when we print some logs, because then it'll be a lot more clear there. But just stick with me for now. So prefix is default. Oops. Scope equals default. We do that. Otherwise, we do some string concatenation. The tag name, scope. Okay, and then we'll get our actual prefix. Comp time, level, dot as text. And then get that. And we'll add that scope prefix. So this will just add some extra information to our logging and make it very clear and easy to understand. So now let's actually do the logger itself, because we'll write to standard error. Undefined. So first we'll get standard error. Lock standard error writer, pass that buffer. And then we defer closing it or unlocking. Nice, and then we'll do our final print, which is the last thing we need here. So we'll do the color. So basically what these color codes do is it tells the terminal what color to print in. So that's why I put the color first. And then the prefix, the format, color.reset to reset the colors afterwards if we need anything else. Or essentially this reset, I guess a better way to say it is anything that comes after, we don't want to put in the color. And then just catch any errors. Got to specify this as being U8s. That's a string. So now, how do we actually start using it? Well, one, the way Zig does it is we define standard options, and it has to be in your main file, but because main file will actually live in every game itself, we just want to provide recommended options, and then that way we can just tell the game to do this or have it in our templates. So let's just create the recommended options. So recommended std options is std options, and then we'll pass that log function, which will be in core log.zig, and it'll be the log. There you go. So now we're passing it. So now if we go over to main, we can do pub const it's std options equals zephyr dot recommended std options. Nice. So now what we're going to do is go back over to root and just get rid of any debug. So std debug print and replace all of those with log.error and make sure, so I just did as I did it everywhere. Make sure you do the same. We do std.log and see I just replace all of those. And we'll do the exact same thing in shader, because that's the only other place. And we're not going to see any logs yet, so let's just go back to root, and I'm going to just add some in. So std log info, starting up application. Nice. And then we'll do the same of shutting down application. And then I also want to show you all the different types. So we can do debug, warn, and error. So if we do that, there we go. We can see all the different types. And now if we also do zig build optimize release fast, so we put it in release mode, we can see no debugs for there. And that's exactly what we want. So let's just get rid of these again. Nice. So now that we're done with logging, I also promised that we would abstract our window. So let's get into that. So again, that's going to be in core. This time we'll do window.zig. And let's start with our imports as always. Standard library and our C import. And the standard c.glfw and glad. c.glad. Nice. So now we're going to start by defining our error types, which just like our shaders, there'll be a few cases where it can fail. So we'll define that. We can have initialize, failed, context load, failed, and memory errors. So we'll also have window data, which is what we store on our actual window struct itself. For now, it's just width and height, but we will add more to it pretty soon. And height. So then we'll also have window params, which this is what we pass into our init function. So you could just have these directly passed, but I like to specify this as it can grow. And you'll notice I'm making them optionals because what I'm going to do is if it's null, we just try and find the default like monitor ratio or monitor values, which that'll help us fix why our quad is not perfectly centered. Okay, so then we'll have two helper functions to do exactly that, to get those default width and height. We'll get default width, and we'll use GLFW functions to do this. Monitor equals GLFW, GLFW get primary monitor, and video mode really, but GLFW get video mode, pass in that monitor, and then the full width. 232, and we'll need an int cast video width, not height here. Width, nice. And then we'll return, have to do a little bit of casting and some proper normalization of the values. But yeah, just a little messy with Zig, but that's okay. Int full width and times 0.5. Okay, and now we're going to do the exact same thing for height. So we'll replace width with height and make that one a capital. Miss this one. There we go. So now let's start writing our window struct. So pub const window equals struct, and then we'll hold on to a window, and then also window data. So window data will be used more as we get into the event system, but that's just there for now. So this will be the definition of our init. So we'll have an allocator since we're going to heap allocate the actual window struct, and then those params. And it will return either the window error or a pointer to a window. And then we will fill this in. It's going to be the biggest function. So let's just write all that, the rest of the helper functions before. So first, let's do vsync. Value bool, void, GLFW, GLFW, swap interval. I think we can do int from bool and value. Yep, that's right. And then let's do handle input. And these are static because they don't need a handle to the actual window. So pull events, which is quite nice. But then these next couple will. Do const pointer to the window. It's going to be void, GLFW, GLFW swap buffers. And be self.window. Then just two more. Function should, and we'll see how all these are used very soon once we start using it. Window, and that'll be a bool. Then return GLFW. Window should close self.window equals 0. Nice. And then our final dinit, which of course we need because we're keep allocating things. Window, and then the allocator. Cd mem allocator be void, and GLFW terminate, GLFW, GLFW destroy window, and then destroy self, because we will keep allocate ourselves. Okay, now let's get back to our init function. Now let's start filling it in. So I'm actually just going to go back to root, because there's quite a bit we can take here. We can take, let's just start with this for now. So paste that in, and then we can immediately do return window error dot initialize failed. And this looks pretty good. Failed to initialize, yeah. But now we're actually going to error defer, because the RDNet will cover terminate, but if any other errors bubble up, we want to make sure we properly terminate. Okay, and now because we can't just pass through a title, let's just do a quick allocation. Allocator dupe z u8 params title and catch error std log error failed to duplicate window title and pass that error through, and then return window error dot memory error. And then after, if that's successful, we will defer the free of it. And now let's get the width and height. So like I said, remember if we passed optionals, so if it was specified, then we want to return that. Otherwise, get default width. And same with height. Width, height, and let's just make that height. There we go. So now we can create our window. GLFW create window, and int cast width, int cast height, pass the title, and these can be null. And now, again, this is similar checks as we've already done, so this shouldn't be too strange. Log error failed to initialize GLFW window, and then return window error dot initialize failed. Nice, and then another error defer to destroy if we have any subsequent errors. So now we can do a couple things like make context current, pass the window, and then we'll also do window set vsync now that we can. Okay, and now I'm going to go back over and copy some code, like this loader code. So that's nice to just be able to do, and then it'll be window error dot context load failed. And now let's heap allocate our window. So const window is allocator, create the type of window, and catch if there's a memory error, which we really shouldn't see, but just in case, handle all the cases. Allocate window error and return window error dot memory error. Nice, and now we can do window. We're going to actually create the type. Equals window, and data equals window data, width equals width, and height equals height. There you go. So now we've created that, and then we're just going to do one extra thing. Again, this is to make sure that our quad goes to the middle, and that's actually setting the proper frame buffer width and height. Int is undefined, and same with height, and then GLFW get frame buffer size, window, frame buffer width, width, and height. And then we'll just need to set the viewport, set viewport 0, 0, FB width, and FB height. And then return our allocated window at the end. Okay, so that's a lot of code, but let's see what it can do for us. So now we can just right away strip all of this and do const window. Oh, forgot to import it. Make sure we do that. window equals import core window and window type. So window.init. Oh, I have to create the allocator, but we'll do that right away. So title is Zephyr engine, and remember width is null because we're going to let it infer, and height is also null. So let's create the allocator. So our GPA equals a cd heap debug allocator, and we will use a more efficient allocator in the future, but for now, as we're just creating things and wanting to get good debugging, we're going to go with the debug allocator. Allocator equals GPA allocator. There we go. So now we have our allocator. And of course, we have to defer window dinit. Let's see. Oh, I didn't catch the error. That's why. So std log error window init failed. And we'll log that and return. Dinit, just the allocator, I believe. So now, again, let's just go clean up some of the code down here. Like here, instead of all that, it can just be window, should close window. And it should be window.swap buffers. Up here should be window handle input, and same down here. And we made one mistake. Let's see here. Do capital Z. And there we go. So we have our window. And again, as you can see now, the quad is centered. And it all works the same. You close it, it's not going to crash. We have our logging. And I know that was a lot of code, but I think we're in a great place now. And that's the episode today. I hope you enjoyed, again, what we did. We kind of cleaned up a couple small things from last time. We added logging, which I think is pretty cool when you can just very easily get those colors and just all the information as you want it right there. Personally, I think that's cool, and that's going to set us up for the rest of the series. You can use std.log anywhere in your code, and it will have the proper colors and everything. And if you want to prepend stuff, like let's say have it log being like Zephyr engine or runtime versus game, we can add that to that function, that custom function that we did for printing. So it's extendable. You can do whatever you want with it. But for right now, I think just adding colors is a really nice thing to have. And then again, we also abstracted our window API. So now instead of raw GLFW functions, it's abstracted a bit. We have it in our window struct, and now it's going to be a lot easier for us to work with next time. And again, I promise the event system next time. We're going to do that. I promise. It might take more than one episode. I'm not sure yet. Still planning it out. But nonetheless, events will come, then input, and then probably the sandbox app, which those all, I'd say, tie in pretty closely together because we want our sandbox app to be able to process these on events and just process events in general, which our input will do. So those are the next 3 episodes for sure. I think it's a lot more exciting than what we've done the last couple episodes. So stay tuned. If you can like the video, subscribe, shows you guys are enjoying the series. I know I've been getting lots of comments that you guys are enjoying it. And yeah, if you have any feedback, again, let me know. Let's see what else. Discord link's down in the description, and the Twitch link, of course, is down in the description. I'm streaming once a week. I'm trying to. Might take a week off here or there, depending on how busy I am. I do have some other videos coming down the pipeline. Some, I'd say, more higher quality videos, as in they take longer to record, make, edit, everything. I'm really trying to occasionally post videos like that. And if that interests you, it's going to be on various topics, whether it be Zig, game engine. Just a hint for this one, it's the 1 billion row challenge in Zig. So if you're excited for that, make sure you're subscribed because it's coming in the future. Again, it'll take longer than these other videos, but I'm excited for that and I hope you are too. Yeah, have a great day.